Today we are going to be tackling integration and differentiation in depth, and it's based on a request of one of the audience. So in terms of KCSE questions, the first thing you need to note regarding integration and differentiation is the relationship between distance, velocity, and acceleration, which are usually abbreviated as S, V, and A respectively. So if you've been given the distance function or the equation and you are supposed to find the velocity equation, you should differentiate the distance function. Then if you've been given the velocity function and you need to find the acceleration of that particle, you should differentiate as well to find the acceleration equation. Then if you've been given the acceleration function and you need to find the velocity of that particle, you should integrate to find the velocity equation. And if you have the velocity equation and you need to find the distance equation, you should integrate as well. So remember, it is SVA in terms of differentiation. S being the distance to velocity, you differentiate. Velocity to acceleration, differentiate. But the reverse, you integrate. Then you are going to look at a few examples which I've extracted from various KCSE papers. Example 1, we have obtained it from KCSE 2010 Mathematics Paper 2, question 11, and it says a particle starts from O and moves in a straight line so that its velocity v meters per second after time t seconds is given by v is equals to 3t minus t squared. The distance of the particle from O at time t seconds is s meters. Part A, express s in terms of t and c, where c is a constant. So remember the introduction, we said if you have been given the velocity equation and you have been asked to find the distance equation, you need to integrate the velocity equation. So in our case, we are going to integrate the velocity equation in order to obtain s. So that means our s will be the integration of velocity, and it's in relation to the time, so it's v dt. Then we substitute v by the equation of v, which is the integration of 3t minus t squared dt. Then for integration, you are supposed to add the power of the unknown by 1, then divide the whole term by the new power that you have obtained. For example, for the 3t, it will be 3t, and since the power of t in the first term is 1, so it will be 1 plus 1, which is 2. So it will be 3t squared divided by 2 minus t squared. So plus 1 becomes t cubed. So it will be t cubed divided by 3. So it is 3t squared divided by 2 minus t cubed divided by 3. Then we have to add plus c because we have not been given the limits of integration. And that is why we had been asked to express s in terms of t and c. So that is how you do the integration. Part B, calculate the time taken before the particle returns to O. So we need to find the time taken before the particle moves and settles. And to do that, we first need to find the times when the particle is at rest, because the time taken before the particle returns to O is the time between the particle was at rest and the next time it was at rest. So in short, the time taken is equal to the interval when the particle is at rest, and when the particle is at rest, the velocity is 0. So we can equate our equation of v to 0, and therefore we shall have 3t minus t squared is equal to 0. We can rewrite this to have the term with the highest power to begin with. We have negative t squared plus 3t is equal to 0. Then we divide the whole equation by negative 1 in order for t to remain without a negative coefficient. So we have t squared minus 3t is equal to 0. Then To solve such a quadratic equation, we can use completing the square method. And if you have any problems using the completing the square method, you can leave a comment. So to do that, we are going to introduce the term c, and c is usually b divided by 2a, and our b in this case is -3, and our a is the coefficient of t squared, which is equals to 1. So we shall have t squared minus 3t plus -3 over 2 squared is equals to 0 plus -3 over 2 squared. So whatever term you introduce in the left hand side of the equation, you have to introduce it on the right hand side of the equation to maintain a balance. Then now this becomes t minus 3 over 2 squared is equals to -3 over 2 squared, which can be simplified to be t minus 1.5 squared is equals to 2.25. Then we find the square root of both sides. We shall have the root of t minus 1.5 squared is equals to the root of 2.25. So t minus 1.5 is equals to 1.5, or t minus 1.5 is equals to -1.5. Then in the first equation, we are going to add 1.5 to both sides, in both equations actually. So we shall have t minus 1.5 plus 1.5 is equals to 1.5 plus 1.5. And on the other equation, we have t minus 1.5 plus 1.5 is equals to 1.5. So it is equals to -1.5 plus 1.5. So t is equals to 3, or t is equals to 0. That means the particle was at rest at time t is equals to 3 seconds and at time t is equals to 0 seconds. That means the particle moved between that time interval. So to find the time taken, we are going to subtract the two values of t. So the time taken is equals to 3 minus 0, which is equals to 3 seconds. Example 2, we have obtained it from KCSE 2011, Mathematics Paper 1, question 22. It states the displacement s meters of a moving particle after t seconds is given by s is equals to 2t cubed minus 5t squared plus 4t plus 2. Determine part A, the velocity of the particle when t is equals to 3 seconds. So we are supposed to determine the velocity when t is equals to 3 seconds. So the first step is to find the velocity equation. And since we have the displacement equation, to obtain the velocity equation from the displacement equation, you should differentiate. So we have our s is equals to 2t cubed minus 5t squared plus 4t plus 2. So the velocity will be the differentiation of the displacement equation in relation to time. And remember, in differentiation, you multiply the coefficient of the unknown term by its power, then you subtract the power by 1. So our v will be 6t squared minus 10t plus 4. Then we are supposed to find the velocity when t is equals to 3 seconds. So we substitute the t by 3. So we have 6 into 3 squared minus 10 into 3 plus 4, which is equals to 54 minus 30 plus 4, which is equals to 28 meters per second. So the velocity when t is equals to 3 seconds is equals to 28 meters per second. Part B, determine the value of t when the particle is momentarily at rest. So remember, our velocity equation that we computed in part A was v is equals to 6t squared minus 10t plus 4. And at rest, the particle is not moving, therefore v is equals to 0. And so we can equate the velocity equation to 0. So we have 6t squared minus 10t plus 4 is equals to 0. Then we use factorization. The factors of 6 times 4, whose sum is -10, is -6 and -4. So we have 6t squared minus 6t minus 4t plus 4 is equals to 0. 60 is common in the first two factors, so we have 60 into t minus 1 minus 4 into t minus 1 is equals to 0. So 60 minus 4 into t minus 1 is equals to 0. And so we have 60 minus 4 is equals to 0, or t minus 1 is equals to 0. In the first equation, we add 4 on both sides of the equation, and in the second part, we add 1 on both sides of the equation. And so we have 60 is equals to 4, or t is equals to 1. We simplify the 60, and we obtain that t is equals to 2 over 3. Therefore, when the particle is at rest, t is equals to 2 over 3 and 1. Part C. Determine the displacement when the particle is momentarily at rest. So we need to find the displacement at rest, and the displacement equation is S is equals to 2t cubed minus 5t squared plus 4t plus 2, and from part B we've obtained that the particle was at rest at time t is equals to 2 over 3 seconds and time t is equals to 1. Therefore, the displacement will be the subtraction of the displacement at time t is equals to 1 and the displacement at time t is equals to 2 over 3. So we substitute, we shall have 2 into 1 cubed minus 5 into 1 squared plus 4 into 1 plus 2 minus 2 into 2 over 3 cubed minus 5 over 2 squared plus 4 into 2 over 3 cubed plus 2. You simplify this, you obtain 3 minus 3.037, and therefore the displacement is negative 0.037 meters. Remember, the displacement can be a negative, but had we been asked to find the distance when the particle was at rest, then we should have obtained the absolute value, which would have been 0.037 rather than negative 0.037. Part D. Determine the acceleration of the particle when t is equals to 3 seconds. We need to find the acceleration, and remember we obtained the velocity equation as 6t squared minus 10t plus 4. So to find the acceleration, we need to differentiate the velocity equation. So acceleration will be the differentiation of the velocity equation in relation to time. So remember how we do differentiation. You multiply the coefficient of the unknown term by its power, then you subtract the power by 1. So this will be 12t minus 10. And we are supposed to find the acceleration at time t is equals to 3 seconds. So we substitute t by 3. We have 12 into 3 minus 10, which is the same as 36 minus 10. Therefore, the acceleration at time t is equals to 3 seconds is equals to 26 meters per second squared. Example 3 has been obtained from KCSE 2012, Mathematics Paper 2, question 24. The question is, the acceleration of a body moving along a straight line is 4 minus t meters per second squared, and its velocity is v meters per second after t seconds. Part A1, if the initial velocity of the body is 3 meters per second, express the velocity in terms of t. So we need to find, in short, we are being asked to find the velocity equation. And to find the velocity equation, the first step is to integrate the acceleration equation. So the acceleration equation is 4 minus t. So the velocity equation will be the integration of the acceleration equation in relation to time, which will be the integration of 4 minus t dt. And to integrate, we add the power of the unknown by 1, then divide the term by the power. So in our case, it will be 4t minus t squared over 2 plus c, because we do not have, the integration is not definite, we don't have the limits. Then we've been told that at the initial velocity was 3 meters per second, so it means at time t is equals to 0, the velocity was 3. And so we can equate the velocity equation, which has a c, to 3. So we have 4 into 0, since the time is 0, the initial velocity, minus 0 squared over 2 plus c is equals to 3. So that means c is equals to 3. And so the velocity equation in terms of t is equals to 4t minus t squared over 2 plus 3. Part A2, find the velocity of the body after 2 seconds. In part A1, we obtain the velocity equation as v is equals to 4t minus t squared over 2 plus 3. So the velocity after 2 seconds is the velocity of t is equals to 2, which is equals to 4 into 2 minus 2 into 2, 2 raised to 2 over 2 plus 3, which is equals to 8 minus 2 plus 3, and it's equals to 9 meters per second. Part B1, determine the time taken to attain maximum velocity. So to attain maximum velocity, the first thing to remember is our acceleration equation, and it was 4 minus t. Then at maximum velocity, the acceleration is 0. And so we can equate the velocity equation to 0. So 4 minus t is equals to 0. We subtract 4 on both sides. We obtain negative t is equals to negative 4. Divide both sides by negative 1, and therefore t is equals to 4 seconds. So the time taken for the particle to obtain maximum velocity was 4 seconds. Part B2, calculate the distance covered by the body to attain maximum velocity. We have established that the time taken to obtain maximum velocity is 4 seconds. Therefore, it's the distance covered between time t is equals to 0 and time t is equals to 4. Then the velocity equation is 4t minus t squared over 2 plus 3. So the first step, we first need to find the distance equation, and to obtain the distance equation from the velocity equation, we integrate. So it's an integration between 4 and 0 of the velocity equation. So it's the integration between 4 and 0 of 4t minus t squared over 2 plus 3, which becomes 4t squared over 2 minus t cubed over 6 plus 3t between 4 and 0. One thing to note is when you have a fraction that you need to integrate, as you are obtaining the new power, where in our case you had we had t squared and it became t cubed, the 3 is multiplied by the denominator, so the new term becomes t cubed over 6. Then we substitute the values of t. We have 2 into 4 squared minus 4 cubed over 6 plus 3 into 4 minus 2 into 0 squared minus 0 cubed over 6 plus 3 into 0, and therefore our s is 33 and a third minus 0, which is equals to 33 and a third meters. Example 4 has been obtained from KCSE 2013 Mathematics Paper 1, question 21. The displacement s meters of a moving particle from point O after t seconds is given by s is equals to t cubed minus 5t squared plus 3t plus 10. Part A, find s when t is equals to 2. So this is a direct substitution. We have our equation of s, which is t cubed minus 5t squared plus 3t plus 10. So we substitute t by 2, and once you compute this, you obtain 4 meters. Part B1, determine the velocity of the particle when t is equals to 5 seconds. So the first step is to find the velocity equation, and we do that through differentiating the distance equation, which is s is equals to t cubed minus 5t squared plus 3t plus 10. So the velocity equation will be the differentiation of the distance equation in relation to time, and it becomes 3t squared minus 10t plus 3. Then we've been asked to find the velocity at time t is equals to 5. So we are going to substitute t by 5. Hence we have 3 into 5 squared minus 10 into 5 plus 3. You evaluate this, you obtain 28 meters per second. So the velocity at time t is equals to 5 seconds is equals to 28 meters per second. Part B2, determine the value of t when the particle is momentarily at rest. So remember the velocity equation that we obtained in part A is v is equals to 3t squared minus 10t plus 3, and at rest the velocity is 0. So we can equate this equation, the velocity equation, to 0. Then we solve the quadratic equation through factorization. The factors of 3 times 3, whose summation is negative 10, is negative 9 and negative 1. So we have 3t squared minus 9t minus t plus 3 is equals to 0. We factor out 3t. We have 3t into t minus 3 minus 1 into t minus 3 is equals to 0. 3t minus 1 into t minus 3 is equals to 0. Therefore, 3t minus 1 is equals to 0, or t minus 3 is equals to 0. In the first equation, we add 1 to both sides of the equation, and in the second, we add 3 to both sides of the equation, and that gives us 3t is equals to 1, or t is equals to 3. We solve the 3t is equals to 1 to obtain the value of t, and t is equals to 1 over 3. So t is 1 over 3, or 3. So the time when the particle is momentarily at rest is at time 1 over 3 seconds and time 3 seconds. Part C, find the time when the velocity of the particle is maximum. To find the time when velocity is maximum, we shall need the acceleration, because at maximum velocity, acceleration is 0. So remember the velocity equation. It's 3t squared minus 10t plus 3. Then from this, we can obtain the acceleration equation by differentiation. So it will be the differentiation of the velocity equation in relation to time, which is 6t minus 10. Then, as we have stated, at maximum velocity, acceleration is 0. Therefore, we shall equate the acceleration equation to 0. So 6t minus 10 is equals to 0. We add 10 to both sides. We obtain 6t is equals to 10. Divide both sides by 6, and hence t is 2 over 3 seconds. So the time when at maximum velocity, time is equals to 2 over 3 seconds. Example 5 has been obtained from KCSE 2015, Mathematics Paper 2, Question 13. Evaluate the integration of x squared plus 2x minus 15 dx between 4 and 2. This is a more generic example where you are performing a definite integration. So the expression is x squared plus 2x minus 15 between 4 and 2, which can be rewritten as x squared plus 2x minus 15 between 4 and 2. Then we substitute the values of x by 4 and 2, and we obtain 9 minus negative 7, which is 16. So using this example, it's more applicable in computing area by integration, and there has been instances in the KCSE papers, like I'm going to enlist below. Instance 1 is in KCSE 2011 Mathematics Paper 1, Question 21, Part B2, where you are supposed to calculate the area bounded by the curve y is equals to negative x squared plus 6x plus 1, and the lines x is equals to 0, y is equals to 0, and x is equals to 6 by integration. So this is similar to the example that we have just performed, where you are supposed to find the integration of negative x squared plus 6x plus 1 between 6 and 0. You can work that out, but if you experience any problems, you can leave a comment. Instance 2 is KCSE 2013 Mathematics Paper 2, Question 23, Part B, where you are supposed to, by integration, find the area bounded by the curve y is equals to 5x minus a half x squared, the lines x minus 6, x is equals to 6, x is equals to 0, and the x-axis. This is the integration of 5x minus a half x squared between 6 and 0. We have instance 3, KCSE 2014 Mathematics Paper 1, Question 21, Part D. By integration, determine the actual area bounded by the curve y is equals to x squared minus 3x plus 6, the lines x is equals to negative 2, x is equals to 8, and the x-axis. This is the same as performing the integration between 8 and negative 2 of x squared minus 3x plus 6. We have instance 4, KCSE 2016 Mathematics Paper 1, Question 24, Part C. Determine by integration the actual area under the curve y is equals to a half x squared minus x plus 3 between x is equals to 1, x is equals to 6, and the x-axis. It's the integration between 6 and 1 over half x squared minus x plus 3. And the final instance is in KCSE 2018 Mathematics Paper 1, Question 22C, where you are supposed to find the area bounded by the curve y is equals to 4 minus a quarter x squared between the lines x is equals to negative 4, x is equals to 4, and the x-axis. This is the integration of 4 minus a quarter x squared between 4 and negative 4. I'd like you to work out these examples, but if you experience any challenges, leave a comment and we shall be sure to tackle them. Example 6 has been obtained from KCSE 2015 Mathematics Paper 2, Question 22. A particle was moving along a straight line. The acceleration of the particle after t seconds was given by 9 minus 3t meters per second squared. The initial velocity of the particle was 7 meters per second. Find, part A, the velocity v of the particle at any given time t. So in other words, we are being asked to find the velocity equation. And to find the velocity equation, we need to integrate the acceleration equation. So our acceleration equation is 9 minus 3t. Therefore, v will be an integration of the acceleration equation in relation to time. So it's an integration of 9 minus 3t dt, which will be 9t minus 3t squared over 2 plus c, because we do not have limits for the integration. But then we've been told that the initial velocity of the particle was 7 meters per second. Therefore, we can replace the values of the velocity and time, since the initial time is t is equals to 0, in order to find the value of c. And that means the value of c is 7. Therefore, the velocity at any given time is given by the equation 9t minus 3t squared over 2 plus 7 meters per second. Part B, find the maximum velocity of the particle. So we need to obtain the maximum velocity, and we know that the acceleration equation is 9 minus 3t, and at maximum velocity acceleration is 0. Therefore, we can equate the equation to 0. So we have 9 minus 3t is equals to 0. We subtract 9 from both sides of the equation. We have negative 3t is equals to negative 9. Divide both sides by negative 3, and we obtain t as 3. Then the velocity equation as we computed in part A is 9t minus 3t squared over 2 plus 7. So we substitute the value of t in the equation of v, and therefore maximum velocity will be 9 into 3 minus 3 into 3 squared over 2 plus 7, which is equals to 20.5 meters per second. Part C, find the distance covered by the particle by the time it attained maximum velocity. So we need to find the distance, and remember the distance is the integration of the velocity equation. So the velocity equation is 9t minus 3t squared over 2 plus 9. Then in part B, remember we obtained that the time taken to attain maximum velocity was 3 seconds. Therefore, to find the distance taken in order to obtain maximum velocity, we shall integrate between time 3 and the initial time. We shall integrate the velocity equation between time 3 and the initial time. So we have the integration of 9t minus 3t squared over 2 plus 7 between time 3 and 0. So the integration of 9t becomes 9t squared over 2. 3t squared over 2 becomes 3t cubed over 6, and 7 becomes 7t. And this can be simplified further to give us 9t squared over 2 minus t cubed over 2 plus 7t, and the integration is between 3 and 0. So we substitute the values of t by the values of 3 and 0, and therefore we have 9 into 3 squared over 2 minus 3 cubed over 2 plus 7 into 3 minus 9 into 0 squared over 2 minus 0 cubed over 2 plus 7 into 0. This gives us 81 over 2 minus 27 over 2 plus 21 minus 0, which we disregard. And once you simplify this, you obtain 48 meters. So the particle traveled for 48 meters before the particle attained the maximum velocity. Example 7 has been obtained from KCSE 2018, Mathematics Paper 1, question 19. However, we had already tackled this question in a different video, so I won't go into the details, but if you'd like to have a look at it, just go directly to the link that appears on your screen. Example 8, which will be our final example, has been obtained from KCSE 2018, Mathematics Paper 2, question 16. Find the value of k if the integration of kx cubed minus 3x squared dx between 2 and 0 is equals to 16. So we are supposed to find the value of k, and the expression is the integration between 2 and 0 of kx cubed minus 3x squared dx, which is equals to 16. So the integration of kx cubed becomes kx raised to power 4 divided by 4 minus the integration of 3x squared becomes 3x cubed over 3, and the integration is between 2 and 0. Then we can simplify this and remain with kx cubed over 4 minus kx raised to power 4 over 4 minus x cubed between 2 and 0 is equals to 16. So we substitute the values of x. We shall have k into 2 raised to power 4 divided by 4 minus 2 cubed minus k into 0 raised to power 4 over 4 minus 0 cubed is equals to 16. This becomes 4k minus 8, and in the second expression we have 0 is equals to 16. So in short, 4k minus 8 is equals to 16. We add 8 to both sides of the equation, and we have 4k is equals to 24. Divide both sides by 4, and we find that the value of k is equals to 6. Do you still have an unanswered question? Leave a comment or write an email to guruinmaths@gmail.com and we shall respond within 24 hours. Otherwise, subscribe to receive timely KCSE mathematics revision resources.